Welcome back to Math 103. This is video number 20 on apportionment. We're getting used to the Huntington-Hill rounding rule, and our practice question is to consider a state whose standard quota is 2.46. The question is, should this 2.46 be rounded down to 2 or up to 3 under the Huntington-Hill rounding rule? So Webster will certainly round this down to 2, but what will Huntington-Hill do, and how can we tell? We have to compare our quota of 2.46 to the Huntington-Hill rounding cutoff, which is the square root of 2 times 3. And where did 2 times 3 come from? Because I take my quota and I look at its lower quota and its upper quota, and those are 2 and 3 respectively. It turns out that this equals 2.4495. It's a good idea when we deal with Huntington-Hill to carry decimal places a little bit further than we're used to. So 2.46 compared to 2.4495, well, 2.46 is greater than this rounding cutoff, so we round up to 3. Even though Webster would have told us, conventional rounding would have told us to round down to 2, from the Huntington-Hill point of view, this number deserves to be rounded up. It exceeds the threshold for rounding up instead of rounding down. To get a sense of how this works in a full-fledged example, let's look again at one of our favorite examples. This is with 38 seats and the New England legislature after some period of time has passed and the overall population has grown to 17 million. We've worked with this example before, and now we're going to apply the Huntington-Hill method, which essentially looks like the Webster method, except that we're now using these new rounding cutoffs instead of the conventional rounding cutoffs. This means that after we've found the standard quotas, instead of rounding 15.647 up to 16 and rounding 8.494 down to 8, etc., instead of applying ordinary rounding, we're going to compute for each state the geometric mean of the lower and upper quotas. So the Massachusetts standard quota is 15 point something, and therefore we have to compute the square root of 15 times 16. The Connecticut standard quota is 8 point something, so we compute the square root of 8 times 9. Maine has a standard quota 4 point something, so we compute the square root of 4 times 5. Okay. Now, I caution you, on your calculator, when you compute this, you have to be careful that the 15 times 16 is getting multiplied first, and then you're taking the square root of that. So you might achieve that by putting the 15 times 16 in parentheses, and then applying the square root, or square root, open parenthesis, 15 times 16, close parenthesis, and then hit enter, depending how your calculator works. So we ask our calculators to compute these. We ask, how much is the square root of 15 times 16? It's 15 point something, but not 15 and a half. Instead, it's a little bit less than 15 and a half. It's 15.492. And the square root of 8 times 9 is not 8 and a half. It's a little less than 8 and a half. Similarly, this square root is a little less than 4 and a half. This one is a little less than 3 and a half. This one is a little less than 2 and a half. All right, so how does this turn out according to the Huntington-Hill rounding rule? So Massachusetts has a standard quota greater than the rounding cutoff, so we round up. Connecticut has a standard quota greater than its Huntington-Hill rounding cutoff, so we round up. Right? Notice, Webster would have looked at this number and said, oh, it's less than 8.5, so you round down. Huntington-Hill says, no, we're not going to compare this number to 8.5, we're going to compare it to 8.485. That is the Huntington-Hill rounding rule. So we compare the standard quota to the Huntington-Hill cutoff, and our standard quota exceeds the Huntington-Hill cutoff, therefore our quota gets rounded up instead of down. How about Maine? Well, for Maine, it was obvious to Webster that 4.4 something would get rounded down, but for Huntington-Hill, this is actually a close call. If this quota had been only slightly higher, it would have reached or exceeded the Huntington-Hill cutoff, and it would have been rounded up. So it does indeed get rounded down, but it came very close to being rounded up. So New Hampshire is rounded down to 4, Rhode Island is rounded down to 3, Vermont, this 2.2 something is less than the Huntington-Hill rounding cutoff, so this 2.2 something is rounded down. Great, so we do all of our roundings, we have our standard quotas, we have our rounding cutoffs, we figure out how to round each quota. We add up these rounded quotas, and we find that the sum does indeed equal 38. That's great news. That means that this right here, these numbers give us the Huntington-Hill apportionment of the seats. Right? This led to the right number of seats being apportioned, so we're done. The standard quotas worked. We're not going to need a modified divisor. Now, in this example, we're lucky. That just happens to be the case, that the sum of rounded standard quotas should equal the number of seats. We won't always be so lucky, and sometimes we will actually have to try out different modified divisors. The punchline of this example is that Huntington and Hill come to a different conclusion than Webster about which way to round this quota, and as a result, Huntington and Hill do get their apportionment just based on the standard quotas, whereas Webster, because he's rounding down here rather than up, is not going to get the correct number of seats, and Webster is going to need to look for a modified divisor. The Huntington-Hill and Webster methods have a great deal in common. Both start out looking at the standard quotas and rounding them, each according to its respective rule, and seeing if those rounded standard quotas produce an apportionment right away. In other words, if the rounded standard quotas add up to the right number of seats. So both Webster and Huntington-Hill start out looking at the same thing. If that does lead to an apportionment right away, great, we're done. And if not, then we'll get too few or too many seats from the standard quotas, and then we're going to need modified divisors and modified quotas. As an example of this thought process, before going on to the next video, consider the same populations as in the previous example, but with 42 seats in total. If we apply the Huntington-Hill method, with the same populations but 42 seats, will the standard divisor give rise to an apportionment of 42 seats, or will we need to use a modified divisor?